Assalamualaikum and hi to all the viewer. My name is Syafiqah Nadira binti Yunus. My metric number is E21A3069. The slide shows my group members' name and metric number. So this video will explaining about our assignment for subject Aft2103. So we have choose the set C data for our assignment.
Hello, my name is Tuan Siti Nurjana binti Tu Adana. My number metric is A21A31C3. Today I want to talk about data descriptive. Statistic is branch of mathematics used to summarize, analyze, and interpret a group of number or observation. Statistics is also the practice or science of collection and analyzing numerical data in large quantity, especially for the purpose of inferring proportion. In a word of those in representative samples, there are two major branches of statistics, which is descriptive statistics and inferential statistics. There are two types of data, namely primary data and secondary data. For this assignment, we use secondary data. Secondary data mean collected data from pre-existing data. There's two type of variable, which is qualitative and quantitative variable. So for qualitative variable, we know that data cannot measure, and for the quantitative variable can be measured. So that's all for me. Thank you.
The next part is 2.0, which is sampling data and record categorical data. The amount of 350 observations have been obtained randomly from the data found by using the software app called IBM SPSS Statistics. For the sampling data, in order to get the sampling data, we determine the ID numbers of the group members in group 3 in order to find out the lowest two-digit ID numbers. Well, the lowest ID number we have found is 12 among the two-digit IDs from the group members. The select case function in SPSS statistics have been used to generate exactly 350 observations based on the 350 plus lowest two-digit number that had chosen by us. So it will be 350 plus the 12. Thus, it will be exactly 350 cases based on the first 362 cases. The picture below are cropped from the sampling data, where it is just a part of it, which is 1 to 20, because the 350 cases is too large to be fit on this slide. So we had only taken a part of it, which is from 1 to 20. Since the assignment didn't including the categorical variables, or we didn't choose the categorical variables in this assignment, so the step to recode the data in SPSS statistics is skipped.
Hi, my name is Nurita Syafiqah binti Sasuddin, 81A2994. So I will present the frequency distribution. Step 1, decide on the number of classes. The formula is 2 power of k greater than n. So 2 power of 9 greater than 350, k equal to 9. Step 2, determine the class interval or width. The formula is maximum entry minus minimum entry divided by number of classes. So class width of H is 6, class width of BMI is 4, and class width for charges is 5,592. Next, part 3.0, numerical distribution measure. 3.1, measure of center tendency, mean, median, and mode. For mean is the average of the sample class. So the mean number of H is 39.46, and the mean number of charges is 14,300. 5,088.52. For BMI is 30.34. Next, median. Median is the middle of the data entry. So we fill up the number into formula. Then we get the median of age is 38.73 and the median of BMI is 13.45 and the median of charges is 9,781 and 0.79. Next, mode. Mode is the value that appear most frequently in dataset. We also fill out the number into the formula, so we get the mode of age is 22.20 and the mode of BMI is 30.34 and the charges is 5,557.59. Part 3.2 Measure of position. Measure of number of the life insurance by age, BMI and charges. We have first quartile, third quartile and the interquartile range. Interquartile range is Q3 minus Q1. For the age, Q3 is 52.19 and Q1 is 26.37. So interquartile range is 25.82. For the BMI, Q1 is 25.76 and Q3 is 34.40. Interquartile range is 8.64. Next, for the charges is Q1 5,061.31 and Q3 18,156.23. Interquartile range is 13,094.92. 3.3 Measure of variation. Range, maximum data entry minus minimum data entry. Number 2, variance. Number 3, sample standard deviation. Range of age is 33.10. Variance is 200.43. Standard deviation is 14.6. And next, range for BMI is 33.1. Variance 52.83. Standard deviation is 7.27. And last, for charges, range is 50,000 and 57.55. Variance is 828,173,151.22 and standard deviation of charges is 28,777.99. Next, shape of data distribution. For age is the shape of distribution is skew to the right, and then BMI, the shape distribution is bell shape, and last for the charges is the shape is skew to the right.
Assalamualaikum and hi, my name is Shafika Nadira binti Yunus. My metric number is Aft2103 Now I explain about the graphical representation. For age group data, we choose to use histogram graph, and for histogram, the x-axis must use the midpoint or class boundaries. So we choose to use the midpoint, which the formula is lower class limit plus upper class limit divided by 2. For y-axis, we need to use the frequency or percentage of the class, and we choose to use the frequency. From the histogram, it can be explained that the highest insert is among the age of 20.5, which have the highest frequency, which is 65, and the lowest number of insert is among the age of 62.5, which have the lowest frequency, which is 33. Now for the BMI data, we choose to use frequency polygon, which same as histogram. For the x-axis, we use the midpoint, and for the y-axis, we use the frequency. From the polygon, can be concluded that the highest number of insert is 88, which have the BMI amount 25.94, 0.55. The lowest number of insert is 1, which have the BMI among 45.955. Lastly, we have represent the charges group data in OGIF graph. For x-axis, we use upper class boundaries, and for y-axis, we use cumulative frequency. From the OGIF, we can see that about 286 insured were charged about 23,385.5 or less for their insurance charge.
My name is Iza Insyirah binti Bahran. My metric number is A21822512. Numerical descriptive measures. This is graph and table that have been created using the SPSS software. There are three types of small values when calculated using SPSS software compared to when we calculated manually with mean, variance, and standard deviations. Well, there are three types of largest value when we calculated using SPSS software compared to calculated manually, which is mean, mode, and variance.
Alright, I will continue the presentation. I will present the 5.2 hypothesis testing, one sample t-test. In step 4 decision rule, we reject none if t greater than t alpha df. Critical region is 1.967 we got from statistic table, and the decision is since t greater than t alpha df, which is 20.744 greater than 1.967, we reject null and conclude that mu not equal to mu 0. Next, pair sample t-test. In step 4 decision rule, we reject null if t modulus greater than t alpha divided by 2 df. Critical region is 2.251 we got from statistic table, and the decision is since t modulus greater than t alpha divided by 2 df, which is 11.073 greater than 2.251, we reject null and conclude that there is a significant difference between h and BMI variables. Next, ANOVA Step 4 Decision Rule, we reject H null if F greater than F alpha. Critical region is 1.408 we got from statistic table, and then in Step 5 Decision, since F greater than F alpha, which is 1.495 greater than 1.408, H null will be not rejected and conclude that the variables are the same.
Next, I will explain about the correlation analysis. Correlation analysis is a statistical technique which is to determine the relation of two variables. Based on the Pearson correlation analysis by using the SPSS, we can measure and determine the relationship and change between the variables. In this study, we have measured the correlation between each BMI and charges. The Pearson's product moment correlation table between each body mass index and charges is a result from SPSS. This correlation analysis table shows that there is no correlation between each BMI and charges. The R value between BMI and charges is 0.214, and between each and BMI is 0.217, with both of its are less than 0.3. Thus, the BMI is associated with age and charges. This is the scatter plot matrix for age, charges, and BMI. Graph 1 shows BMI against age, which means the older the insured, the higher the body mass index. Graph 2 shows BMI against charges. This means the higher BMI, the higher charges. And lastly, graph 3 shows age against charges. The older the insured, the higher the charges.
This is the 5.4 part, which is the confidence interval. Confidence interval is a range of values that will expected to happen in the population parameter. Several significance level will be used to determine the confidence level, which are 0.01 significance level, 0.05 significance level, and 0.1 significance level. The result will be calculated by using the SPSS statistics, which we have brought from or copied from the output of an SPSS statistics at below. which are 3 pictures showing the confidence interval with different significance level. For comparison, while the standard error, mean, median, variance, standard deviation, minimum, maximum, range, interquartile range, skewness, and the kurtosis are the same among the three tables with the significance level, which having the different significance level. However, the lower bound and upper bound for the confidence interval are different. As for comparison, the range of 99% confidence interval is the highest between the lower bound of 12143, 17743, and the upper bound of 15608.908, while the range of the 90% confidence have a lowest range of confidence interval with the lower bound of 12773.0919 and the upper bound of 14979.5892.
Next, prediction and modeling. According to the model of life insurance, just is negative 8032.837, and the value of the life insurance will be increased by 388.974 for each increase of 1 unit of the body mass index BMI. Moreover, for each increase of the 1 unit in the number of insured age from the value of life insurance, we also make the charge increase by 253.736 for standard disease beta coefficient. The value of A is 292, which is 115 higher than the value of BMI, which is 177.7. At 95%, confidence interval, the lower bound and upper bound of BMI is 170.232, 607.715, while the lower bound and upper bound of age is 167.313 and T40.158. This shows that the two variables are a significant predictor as a value of 0 did not fall in the interval. So that's all for me. Thank you.
Conclusion. To summarize, we can complete all the statistical calculation required for this report using the data gathered during our lecture. We utilize a 350% sample data set, which is age, BMI, and life insurance costs. To complete the graphical representation, we calculated the class interval, frequency, cumulative frequency, relative frequency, midpoint, upper and lower bounds. For some of these values, the difference between the manually calculated and the SPSS system is very large, especially for standard deviation and variance. But for some, the difference is small. In contrast, there are no difference between the manually calculated and SPSS output for the range, maximum and minimum of the data entry. That's all from us. Thank you.